Hey, what's good? My name is Priscilla.
And my name is Jasmine.
And we're from Yes Prep Southwest.
We are juniors, class of 11. Woo woo! And today we will be presenting to you all our pre-calculus project, which is application problems of sinusoidal functions.
It is 2 problems. One is easy and one is kind of difficult.
So we shall get started.
Okay, problem 1. Back on the Ferris wheel. The center of the Ferris wheel is 60 feet above the ground. The radius of the Ferris wheel is 50 feet. The Ferris wheel takes 4 minutes to complete a full revolution and is moving in a counterclockwise direction. This is the Ferris wheel, as you can see. And on the back, it shows like details of it. So it's 50 from the center to A. It takes 60 to go, like 30 seconds to go around to each part. And then the building is 40 feet tall, and from the Ferris wheel to the building is 100 feet. We're going to start with the first problem. Jasmine's going to take over from here.
Okay, number 1. Sketch the graph which relates the height of car B as a function of time, t, in minutes. So here's the graph. And these two will be the maximums. The y values are both 110, and the x values will be 30 and 270. The roots will be both at 60, and it'll be 90 and 210. Another root will also be at 330 and 60, and the minimum is at 150 and 10. Number 2, determine the sinusoidal equation which models this situation. So here are our 2 formulas for the sine and cosine. So as you can see, once you find the amplitude and the midline, you will be able to solve for the equation. So the equation will end up being 50 times the cosine of pi over 120 times x minus 30 plus 60. Number 3, using this equation, determine the exact height of car B after 3 minutes. 3 minutes is 180 seconds. If you plug it into the equation, it'll end up coming out to this. Number 4, at what time or times will car B be exactly 75 feet above the ground? Use your graphing calculator, people. So when you use a graphing calculator, TI 84 or 83, and y1 you will put 75, and y2 you will put the equation, and where they intersect, this coordinate will come out. Number 5, determine the period, amplitude, midline, maximum, and minimum values for this function. Once you find the period, the midline, and the amplitude, and the midline, you will be able to find all the things that you need for this question. And also, you need to find the minimum and maximum. So here are your answers. Number 6, are there any other ways to represent the sinusoidal function that you created in step 2? If so, create at least one more. This was the original equation, and this will be the new equation. And now for problem number 2.
Problem number 2. Okay, population modeling. So this is the table of the population since 1920. Okay, graph the data by hand. So you would, from this chart right here, you would use it to graph how it would look. Graph the data on a graphing calculator to find a function p of t and try to model the data using sinusoidal regression. If this does not work, then you will need to do your best to eyeball a sine function which models this data. So you have to use your graphing calculator again. You go to Stat, Edit, plug in the points. Then you go to Second Stat, Calc to find the formula. Then you go down to Sinreg and click enter. Then you would end up with this equation. What is the maximum population, and when did this occur? Minimum and when. The max is at 104,000 people after 10 years. The min is at 76,000 people after 70 years.
And remember, all you have to do is use your graphing calculator to find this information.
D. When will the trend complete a full cycle? It will complete a full cycle in 104 years. According to the chart from earlier.